Hello, welcome. My name is Sardarsan Shah. Today I am going to teach you O-level computer science 2210. I hope you will get a lot of information and get knowledge and will be able to get good grades in your final exam. So, what we are going to do is to follow this Cambridge Assessment and Education syllabus, and it is already in, at your online. Its availability is there. And now, what will we do? I am going to show you that this is a complete syllabus which you can download from your website, online or Cambridge website for this purpose. And we will see one by one all of these questions by following the book. Here, we will do this is the way we will try to focus on that. Computer system, data representation. We will do computer system here and data representation, data transmission and the hardware. And then there comes the software and the internet uses, hardware. And listen, this is the first part. Is the paper one. Paper is about exactly 1 hour and 45 minutes. And its weightage is 50%. And total marks are 75. And second is the algorithm programming logic. Algorithm, we will cover algorithm design and problem programming, databases, and Boolean logic. Okay, this is the base. This is the, topics, and now we are reaching to that. Computer system data representation, what we will learn here, understand how and why computer binary to represent all from data, and it continues, but we are going to follow the books to clear your concepts. This is our first lecture. I hope you will learn something from this lecture. If you are new to our channel, you can subscribe to our channel and press bell icon. So let's move forward to see our book, which we are going to follow. Cambridge Assessment Internal Education book. Here it is. We are following this book by David Watson, Ellen Williams. You can download it on internet. It's easily and free available. And you can also, if you want, we can also forward you. I will share with you email address at the end. You may contact us for this book. So let's move ahead, and we are going to start our first, topic of course. Here it is. This is content. We are going to start with computer system, data representation, data transmission, hardware, and so on. And similarly, we will continue software in internet user, automated emerging technologies, and then second part we have already told you, and we are going to start our first lecture right now. Here we come, section 1, computer system, and it contains 6 chapters: data representation, data transmission, hardware, software, internet, and user, automated and emerging technologies. So first of all, we are going to look into data representation, and then we will move ahead one by one. Okay, first of all, we must know about the binary system number system, binary representation. Listen one thing, computer can understand only the language of binary, which is 0, 1. Okay, 0 bit and 1 bit. Okay, we can call bit as a dot, which computer can understand is a binary language. So that's why everything, whether it is a decimal number, hexadecimal number, is in a text format, it must be converted into binary number so that computer can process the data and give us final output in the monitors, etc. Okay, I'm not going to study thoroughly this book because this is your, you can study this book, and this is mandatory for you to follow this text, which we are going to teach basic concept from it. That's why I am following this book, and I am going to elaborate one by one the main books over here. Okay. We can call these the ones and zero as a switch that where the logical gates are there, which we feed the input to the gates, and then it will be represented with output. We can consider if switch is on as a one in which is equivalent to one binary one bit one, and off stage of the switch is considered as binary zero, and in this way we will proceed further. And this is considered logic gates as well. Okay. And now, what is binary system? And very important. Here we go. It's a binary, and then there's a denary, and then there's a hexadecimal system. So binary, we have already told you that it contains 0, 1, but in denary, its base is 10. Just like in common, in counting, we go from, 1 to 10 in 0, 1, 2, 3, 4, up to 9 and 10, and then 11, 12, 13. This is the denary, basically decimal system we are following. But another system is hexadecimal. It means this base of 16. So it's a very easy format for understanding for human. If we are we try to binary bits are very easily converted to hexa symbols, so that human can read, understand, and can write up. So what is binary system? Now we are moving toward that system. Okay, we are already familiar with the binary system, but what about if we want to write it? So many of us know that, but I'm going to recap it through this book. So we write in that way from right to left. 10, 0, power 0, 10, 1, 10, 2, 10, 3, and so on. When we write these, numbers in this format. So 10, 0, and numbers with power 0 is equal to 1, always 1, okay, and then 10, and 10, 20, 100, and 1000. And these values are very mandatory. So if we write 25,177, we can write it in that way. Now, if we want, if someone asks what is the value of this 2, so 2 is always multiplied with 10,000 is 20,000. And then similarly plus sign, and these are the added, and 5 into 1,000. This is at 5 into 10, 1,000. So it is equivalent to 5,000. So 20,000 plus 5,000 plus 1 into 100 plus 10 and 1. It's exactly when you add into it, we will get 25,177. I think this is the basic contents for denary 0 to 9 concept is there. And we also call denary system a decimal system, and it's a 10 number system. That's great. I hope you got it. And now we move forward for binary system in a similar way. The binary number system is based 2 number system. It is based on the number 2. That's only the two values, 0 and 1. Okay, this is 0 and 1 can be used in the system to represent all values using the same method identity. This gives the heading. No, we will replace 10 because the base 10 was there, but now here base is 2. So we will write as a 2, 0 when we are writing, binary number. So 2, 0, 2, 1, and so on up to 7. And similarly, we can write 2, 0 is equivalent to 1 and 2, 4, 8. And similarly, what we did for denary system. I hope you got it. Now, if we want to write this binary number, it's 8-bit number. Okay, 8-bit number. So what will be how can we write it? We can write in that way. And similarly, we can convert from binary to denary, denary to binary. Let's look into it further. Here it is. The conversion from binary to denary is a relatively straightforward process. It's very easy. Each time if one value appears in a binary number column, the column value heading is added to a total. This is also is best shown by 3 examples, which use 8-bit, 12-bit, and 16-bit number. Now, it means that we are going to show you 3 examples in this book, and we are following. Example 1 is a 8-bit number, and then example 12-bit is example 2 is a 12-bit number, and 16-bit number is also there in the example 3. So let's look into the example 1, because remember we are converting from binary to denary in these to denary are based 10 system, decimal system. So convert the binary number. This is the binary number in a denary number. Very easy. 1, 2, 4, 8. That's we have already understood about it. Here it is. We were right in this format. Now, if we want to convert it Denary, equivalent to the Denary will be, so simply from left to right, we move forward. Where there is a 1, we will multiply it to its value. Okay. 1 into 128 is equal to 28, and 1 multiplied with 64 is 64. 1 multiplied with 32 into 32 is 32. We will add just like in Denary system. But 16 into 0, something is 0 is equal to 0. That's why we ignore it. And 1 into 8 is 8 plus 1 into 4 is 4. And 1 into 0 is 0. 2 is 1 and 1 is 0. So when we add all these numbers, we come up with the result of this one, dear students. I hope you got it. Okay, here we get the result of this one. Okay. Okay, so we have achieved that. I hope you got it. Now we move forward 12-bit number. Similarly, we move for 1, 2, 4. Because its power to the 2 is always increased, and then its equivalent is written in this form. This is very easy. If we increase the number from right to left, 1, 2, 0 to 1, 2, 2 to 3 up to this number. Because we are now using a 12-bit number to convert into our Denary number. Here it is 1024. This one is ignored because it is 0. So 1 into 1024 is 1024. And similarly, 512, here it is. And 256 is here. 120 is here. 64 ignored. 32 ignored because 0 is the result. Is a 0, 8 and 2. And when we add these numbers to, we will get the equivalent for that. Here it is. That's great. I hope you got it. Now, when we go for converting the following binary number into it, this is a 16-bit binary number, a third example. Similarly, we make a 1, 2, 3, 4 same format after to give 2, 0, 2, 2, 15, and equivalent value is written here, and then we write this number. And now, similarly, here it is. We will from where did we? From where when we start, here is ignored because result is 0. Here is result 8192. 8192 is the result here, 4096, and then all these numbers are ignored, then 256 and so on. And we will get this result. I hope you will, whenever you do that, you will get the same result. Okay, this is very easy. I think there will be no problem for you to convert these number into that, and you will get the same result. Okay. Now this is the activity in the book. I hope you will do it very easily, and there will be no problem for you. And in the same format, you can write it down and do your practice. If you have any difficulty in solving this question, you may contact us. You may comment us. I will try to give you answer in a brief manner. Next topic is converting from Denary to binary. Okay, just like from binary to Denary, now we are reversing the process from Denary number to binary one. Now here is the how can we proceed that? Okay, then for made of. Okay, this is the way we can write similarly here in this format, and here we go. It's number 1000 and 1110. Binary number is there. Now we want that. To get the decimal number from this, you can, binary number from that, we can get 142 is our, 142 is our number. So first of all, what will be the highest number? We are using 8-bit, 8-bit for it. So 227 will be 1, it automatically. Now, you can recognize it. What will be the next value? So that 120 are there, then 14, we will have to 14, 1, 1, 1. So here it is. If we add this, and we will get 144. So in this way, scheme, but second method is a very, I think, well-known and very easy as well. So we try that by dividing, we can divide any number with 2, and we will, remainder will be putting aside one side. Here it is, 142 is the example is same for method 1. Here 2 is divided by 71 is the answer, and remainder is 0 after dividing it. Then when we divide 2 When divide 271 with 2, a remainder will be, 1. Okay. Here we did 32 and 1. And then similarly, we move ahead 17, 1 remainder. And then here it is 8, 1 remainder. And 2, 4, 0 remainder. 2, 2, 0, 1, 2, 1, 1, 0 remainder. Then it's all okay. Now we from bottom to up, we write down here the conversion. This is a binary number equivalent. Oh, sorry. Like, so here it is, here it is, here it is. This is the equivalent of 1000111. Here it is. It has been written and a very easy way to convert it to in that. Okay. Now, similarly, for you can count 59. Here we go. Here is the first method, and then second method 2 divided by 29, 1 remainder, and so on. I hope you will attempt this question. There is nothing, no, nothing will bother you in this case. I hope you will solve it easily. Okay, and similarly for example 3 is a 16-bit, 35,000 is a number, so we can move ahead to do a solving, and similarly divided by 2, it's a long process, it's in that way, and we will get this result. It's a very easy and following same pattern as earlier, and we will go here. Here this is moving in this way, but here because lack of space, we are writing it here. So this is our example 3, and you can do and perform activity 1.2. You will solve at your home. If there you have any issue, you can tell us. But I am going to try for 41. Simple is that simple method. I am going to show you 41 is this is a number. Here we go. Okay, we are dividing with 2. Simple method. In the second method, utilizing 20. We can simply dash it out. Okay, let's like an okay, here the result will be 1 because we divide and remainder is 1, answer is 20, and then 1. Once again, we divide 20 to with 2, so 10 will be the, it will divide it to by 10 and get the 0 remainder. Then we will continue, dear students, in that way, 2 into 5, sorry, because I am writing in computer through my mouse, that's why it's looking something clumsy looking, but I hope you are understanding and getting these valid points. Okay, 0 is the result, and then 2 is will be there, and we are here to result is 2, and remainder will be 1. Okay, and then here we move forward 2, and here it's a 1, and result will be 0. Then how we will move forward here in this way? If you move forward, you can move here 1 0 1 1 0 0 1. It's the result. It's let's look into it. Here is the result 1 0. You will practice by hand as well. I think you will get the same result. Okay, here it is. Here it is. Here's 1 0 1 0 and 0 1. Okay, and here it is 0 1. Now very easy. This is the answer to that. Is it? Answer to it. Okay. No, very easy. Its value is 1. Its value is 1. And then you move forward. Go for 8. Here is 8. And similarly, this is 32 and equivalent to 41. So that's it for today's lecture. This was the lecture. I hope you have got understanding about your basic concept. If you have any question, you can question me. My email address is Syed Safdar Hussain Shah @gmail.com. I want to, uh, write down here. My email address is will be written here. I hope here it is. Here it is. I'm going to write it. Here it is. I'm going to write it. Sorry. Here we go. Here we go. This is our email address, Syed Safdar Hussain at gmail.com. You can email me. I will give you answers. You may also comment below the video. Thank you very much. See you next video.